Hello everyone. In this video, I want to talk through the lab 3. We have two objectives. The first objective is to observe the step response of a series RC circuit. The second objective is to determine the capacitance of the capacitor through experiment. The equipment we need are lab kit and the DMM. So basically, you need to build up this RC circuit, right? You have power supply, switch, resistor, and the capacitor. You connect them in series, right? I think that should be straightforward for you at this point. The resistor we will use is 100 kilo ohm resistor. The capacitor, you only have one capacitor in the lab kit. The capacitance is 100 microfarad, which is written on the capacitor. To select a resistor, you should have 10 resistors. They have different values. They're color-coded, but we don't learn the color code in this class. What you need to do is use your DMM to measure those resistors and select the one that has 100 kilo ohm resistance. You basically have two resistors that have 100 kilo ohm resistance. Right. You select it and build up this circuit using your lab kit. The one thing I want to point out is the term, the positive and negative terminal of the capacitor. Right, the capacitor we're using has positive and negative terminals. The longer lead, right, the longer terminal of the capacitor are the positive terminal. The short one is negative terminal. You want to make sure that the currents enter the positive terminal of the capacitor. So you look at this schematic. What you can do is you connect the shorter term to the negative terminal of the power source. Make sure you do that. This can prevent unwanted smoke, flame, and even explosions, right? Even you connect it in backward, the chance to have the smoke is low. But make sure that you connect the negative terminal of the capacitor to the negative terminal of the power source. You make sure that the current enters the positive terminal of the capacitor. And that is super important. Okay, so this RC circuit, at T equals 0, close the switch, you know that how the VC change, right? So let's draw it this time. The vertical is VC. Before that, assume that there's no charge in the capacitor, then the voltage is 0. Once you close the switch, the voltage will go up until it reaches 12 volt, right? That's what happens of the VC, right? So in this lab, we're gonna observe this response, right? It's called transient response. We're gonna observe this response, right? So what you will do is you use the DMM, measure the voltage across the capacitor, and then you turn on the switch. You continuously measure the voltage across the capacitor, and you take a record. For example, every 3 seconds, right? You take a record. But, the time is not scaled, right? So you take a record, right? Until, I guess, you can calculate the time constant, right? Tau equals R times C. In this case, and this is 10 seconds. Okay. Of course, then after 5 tau, the capacitor will be fully charged. Right. Then you may want to take a record of longer time, for example, 70 seconds. Right. You take a whole bunch of measurement. Right. And from that measurement, you can create this plot. That's the idea. So that's what you will do in step 4 and 5. So basically, you will create this table, right? Time and VC, right? And when time equals 0, the VC is very close to 0. When t equals 3 seconds, you take a measurement. When t equals 6 seconds, you take a measurement until you reach maybe 70 seconds, maybe I think 69, right? Seconds. If the time interval is 3 seconds, you're pretty much gonna end up 69, right? And you have this data you can plot, you can make that plot. Okay, step 4 and 5, you need to create this table. All right, that's what you will do in step 4 and 5. Take the record can be tricky. Here I have some hint for you. So step 5, we turn on the switch, we record both time and the voltage. Right, that's what you need to do. Cross the capacitor. So you can take a video of the DMM voltage reading. You have a DMM, you just take a video. You start the video at the time you turn on the switch, right? Later on, you can replay the video to take the record, right? You can play the video a little bit slower so that you can take the records, take the time and the voltage, right? You may need a helper, right? Find a friend or a family member to help you, right? You turn on the switch and your helper and take the video for you. And the other thing you can try is you can put a timer beside the DMM, right? And so you can start the video a little bit earlier. Now you can press the timer and turn off the switch at the same time. Then in your video, you have a timer beside with a DMM. You have the time and the voltage all together. You can later on watch the video, write down the numbers. Okay, you can try a way that you like. Okay, that's step 4 and 5. You just get the table basically. Okay. Once that's done, whenever you want to reuse the capacitor or you want to recharge it, you need to discharge it. Remember that the capacitor can hold charge. The voltage will be maintained around the 12 volt. Right? Before you discharge it, you cannot charge it anymore. Right? That's step 6. And before you reuse the capacitor or you put it into the box, you make sure you discharge the capacitor. You don't want to put some energy, on the capacitor and then leave it in the box. Right? That can be dangerous. Right, that's what you need to do in step 6. You basically create this this schematic, and the capacitor will be discharged, right? The current will flow and all the energy will be dissipated by this resistor, and sooner or later the voltage across the capacitor will become 0. Right? Don't short the capacitor, right? If you short the capacitor, it will create a very big current that can be problematic, right? You may see smoke, flame, etc. Right? Do not do that. Make sure you connect the capacitor in series with a resistor and discharge the capacitor. Okay, so that's step 3. Step 7 is this. You repeat step 4 and 5. Now, but this time you measure the voltage across the resistor. You should expect that the voltage across the resistor will decrease, right? Something like this. Okay, and you measure the resistor. You create another table, right? VR. So I think this is TVR, right? So every 3 seconds you take a record, and later on you can create the plot. Once it is done, make sure you discharge the capacitor. Always discharge the capacitor after you fully charge it. All right. So now let me talk a little bit more about this time interval, right? I'm suggest you use 3 seconds, right? So basically, the smaller the time interval, the more data you will get, and the more precise your plot would be, right? But there's trade-off, right? You don't want to record too many data, right? So you can use 2 seconds, 4 seconds, 5 seconds, right? You pick one that you like. And you basically calculate tau. We have to calculate the tau equal 10 seconds. You want to record 70 seconds so that you want to see the fully charged curve. Right, then you select a time interval based on how many data points you want to have. Okay, that's how you determine a time interval. All right, that's part one of this lab. In part two, so you basically plot the data you obtained from part one. Right, you can use some spreadsheet, right? Excel, for example. You create a plot of the voltage across the capacitor and also the current in the circuit, right? You can calculate the current like this using this formula. All right, I equal to VR over R. Right? You have the measurement of VR. You can calculate the current. And then you observe the 2 plots and comment on the relationship. Right? You have KVL, Ohm's law. You can find the relationship between the VC and the current. Right. Also, you have the relationship VC equal to IC equal to C dV dt, right? Those kind of relationship. Okay, you just make some comments. From the voltage plot, determine how long it takes for the capacitor voltage to read approximately 63%, right? You know the final is 12, and you can find where is your 63% of the 12. And that time, that corresponding time is the time constant tau, right? You find that time. Right? In step 4, you using this formula to calculate the capacitance. Assume that you don't know the capacitance, right? Suppose you got a capacitor that's not labeled as capacitance, and you don't have the right meter to measure the capacitance, right? It's required to measure the capacitance. It requires a more specialized meter. Suppose you don't have it, then you can use you can build an RC circuit, right? You find the tau. If you know the resistance, you can calculate the capacitance using this formula, right? That's the purpose of step 4. Okay, this is also our second objectives. Okay, the last step is calculate time constant that you would expect if the capacitor were placed in series with the 3.3 kilo ohm resistors. Right, that should be fairly straightforward for you to do. All right, so that's what I want to say about this handout. In the next video, I'm going to give you a quick demo on how to do this. Thank you for watching. See you next time.